Panama Papers, Gorilla, Financials. It's Monkchips in 3 minutes. So last week I went to a reception that Neo4j put on. It was a bunch of their customers showing off how they're using their graph database. What is a graph database? Basically it's a database that stores graphs natively rather than putting things columns and rows like you do with a relational database. Storing the graphs natively so you can have better performance for querying and basically traversing that graph. Neo4j, interesting company. They've gone out there, done a lot of education about what does it mean to use particular data stores for particular types in this kind of post-relational era. But I want to talk about the Panama Papers. It's not a massive set of data, it's like 2.6 terabytes. But it's all about complex interrelationships between things. And what do the queries look like? I mean, how do you identify financial malfeasance, basically? They tried originally to do it with a relational database, but from the journey they went on was when they wanted to represent the interrelationships between things, they thought a graph made sense. So that was a front end. And then they kind of thought, well, this front end we've actually got to start thinking about, well, what's the back end? And they found a supply called Lincurious. That got them into using Neo4j. Mark Cabra, their head of data, basically has made decisions to do this. They've worked really effectively together, journalists across the world. Clearly, from Neo's perspective, if you're trying to find a use case that everyone knows about, boom, they've got one. There's a brilliant blog called The Morning Paper. It's written by a guy called Adrian Collier. I thought one that went this week was really interesting. It's about a database, in-memory database called Gorilla, used by Facebook to manage their operations, store the logs. The thing about Facebook is just intense and amazing scale. So this database is dealing with 1 trillion events per day. So think about that, 1 trillion. That's a lot of commas. So in Silicon Valley, we talk now about they're talking about the 4 comma club. Facebook is definitely well and truly in that club. So what do? They store like basically 26 hours of this data in memory. The compression algorithms are really interesting. Read the paper to check that out. We're in an environment now where we're trying to understand scale. On the other hand, you've got an organization like Facebook. How many of us really have the problems they do? So they're using Gorilla as a front-end HBase. It's a really interesting paper, really interesting architecture, and this just enables them to manage their operations, not fall over, and do logging of every event across their network and have it highly available. I mean, I think that's one of the interesting things as well. So they're optimized for writes, millions of writes per second even, and that's just extraordinary in terms of scale. But yeah, it's available because obviously if Facebook goes down, they need to be able to find out why as quickly as possible. So everything else is archived to HBase. It's an interesting paper, you should check it out. Talking about Facebook, let's talk about financials. Last week they absolutely smashed it. Really impressive set of results. Amazon did the same. They're both doing really well. This cloud phenomenon continues to drive Amazon's profits. And after some somewhat depressing results from the enterprise vendors, it's kind of interesting to see this transition continue to happen. That's Monkchips in 3 minutes.